Welcome to our deep dive into the world of sampling methods. You see, just like how we can't study every single star in the universe to understand its vastness, we often can't study every single member of a population to draw conclusions. That's where sampling comes in. Today we'll explore 6 different types of sampling techniques and understand their unique characteristics. We'll uncover their strengths, their limitations, and when each method is most appropriate. Think of it like choosing the right telescope for the right cosmic observation. Each has its purpose. From the elegant simplicity of simple random sampling to the more nuanced approach of purposive sampling, we'll journey through the fascinating world of data collection and analysis. Buckle up, it's going to be an insightful ride. Imagine you have a jar full of marbles, each representing an individual in your population. Simple random sampling is like picking marbles out of the jar randomly, with each marble having an equal chance of being selected. It's the fairest way to sample, like a cosmic lottery. This method is great for getting a general sense of the population, especially when you don't know much about it beforehand. Think of it like taking a core sample from an asteroid. It gives you a glimpse into the composition of the whole thing. However, just like you wouldn't rely on a single asteroid sample to understand the entire asteroid belt, simple random sampling might miss out on capturing the diversity within a population, especially if it's very large. Now, let's say you want to study different types of stars in a galaxy. You wouldn't just pick stars randomly, would you? You'd divide them into groups: red giants, white dwarfs, neutron stars, and then sample from each group. That's stratified random sampling. We divide our population into subgroups or strata based on shared characteristics, ensuring representation from each group. This allows for a more nuanced understanding of the population's diversity. It's like comparing the compositions of different planets in a solar system. You get a clearer picture of the overall makeup by analyzing each planet separately. But remember, this method works best when you have prior knowledge about the population's subgroups. Think about studying galaxies across the universe. It's impossible to travel to every single one. So instead we might group galaxies into clusters and study representative clusters as a whole. That's cluster sampling in action. We divide our population into clusters, often based on geographical location or natural groupings. Then we randomly select entire clusters to study, which can be more practical and cost-effective. However, it's important to be mindful of potential biases. If the clusters themselves are not representative of the entire population of galaxies, our findings might not be accurate. Imagine you're an alien visiting Earth for the first time and you land in Times Square. You might conclude that all humans are always in a hurry and wear bright clothing. That's the danger of convenience sampling. It involves selecting individuals who are easiest to reach, even if they might not represent the entire population. While convenient and cost-effective, this method is prone to bias. It's like studying the atmosphere of a planet only at its equator. You'll miss out on the poles and the variations in between. Let's say you, as our alien researcher, want to ensure representation from different Earth continents on your spaceship. You'd set specific quotas like 2 humans from Asia, 3 from Europe, and so on, and actively recruit participants to fulfill them. That's quota sampling. It aims for a sample that reflects the proportions of different subgroups in the population. While it attempts to address some limitations of convenience sampling, it can still be prone to bias in how participants are selected within each quota. It's like assembling a crew for a spaceship. You need a balance of expertise and backgrounds for a successful mission. However, just filling quotas doesn't guarantee you have the best team for the job. Now, if you, our alien friend, specifically wanted to understand human technology, you'd want to talk to engineers and scientists, right? You'd use your judgment to select participants who are most knowledgeable about the subject. That's purposive sampling, a non-probability method where the researcher handpicks participants based on their expertise or specific criteria relevant to the study. This method is valuable for in-depth qualitative research, but it's not meant to be generalized to the entire population. It's like interviewing expert witnesses in a cosmic court case. Their testimonies provide valuable insights, but they don't represent the entire universe of perspectives. Remember, probability samples like simple random, stratified random, and cluster sampling aim to be representative of the population, while non-probability samples like convenience quota and purposive sampling do not guarantee representativeness. It's like choosing between different spacecraft for your mission. Each has its own strengths and limitations. It's important to note that representativeness and bias are not guaranteed in any single instance of sampling. Just like observing the universe from Earth has its limitations, every sampling method has its blind spots. The key is to be aware of these limitations and choose the method that best suits your research question and resources. Thanks for watching. Don't forget to like, share, and subscribe for more insightful content. Keep exploring, keep questioning, and keep looking up at the wonders of the cosmos.